Hello YouTube, my name is Tomasz Krajewski and I'm tech lead at Frontend House. Probably you know me from the Frontend News podcast, but today I'm here at Frontend Expert to share with you a really hot and awesome topic, which is Micro Frontends. Why it can be interesting? Well, it gives a different approach with how to deal with the modularisation in our apps, so it's worth to know how to deal with it in a different ways. Are you interested? Enjoy, check it out, and leave a comments. Thank you. Okay guys, as I promised, we are going to speak about Micro Frontends foundations. Let me share the agenda at first. So we will speak about software architecture, monolith architecture, distributed architecture, and then we are going to speak about Micro Frontends, discuss is it really worth to use in our projects, and I would like to share the Vanilla.js example to show you how to deal with the Micro Frontend setup. At the end, I would like to summarize everything, and I hope you will enjoy the whole show. So, at first, let's speak about software architecture. In short term, the software architecture is about organizing the whole system, where we need to define the components, relations between the components, environment, rules, and design patterns. Monolith architecture is the example of the architecture that is using the single application to encapsulate the whole business logic and other problems that are related to creating our app. It means that the front-end layer, business logic layer, and database layer are closed in terms of the single app. For example, Ruby on Rails app. The pros and cons of using the monolith architecture are at first, as I've mentioned before, we encapsulate all problems and solutions under the single application. On complexity growth, unfortunately, it's hard to scale such applications. Security of data storing and communication is easy to achieve or easier than on the distributed architecture, but I will explain that later. We have reduced palette of technologies used to resolve certain problems. Unfortunately, using the monolith architecture has lack of modularity, and it's really hard to take a single piece from our app and inject it somewhere else. But what is good? The monolith architecture is good for startups and for very first start of the company app, because it's really easy to start development. You do not have to take care of configuration, the complex ecosystem, and define the relations between each of the parts. Another example of architecture is distributed architecture. In previous example, we were closing all of the logic under the single application. Distributed architecture has different assumptions, so it's mostly focused on the backend side, but I'll try to prove later that it also reflects the frontend. But yeah, first thing first. So the distributed architecture assumes that we split our business logic into single apps that resolve the predefined, the certain part of the business functionalities. So for example, instead of having the monolith Ruby on Rails app, we can define 3 microservices that will deal with the specific problems. For example, patients microservice that will contain the patient API and patient database, hospital microservice that will be responsible for resolving the hospital related logic, and auth microservice that will be responsible for authorizing our users. What is worth to mention that in distributed architecture we have also included something that is called gateway, API gateway to be more precisely. API gateway is being responsible to take care of the communication between all of these microservices and expose the single API to the rest of the world. Hopefully it makes sense for you. And pros and cons of this approach. So Microservices and distributed architecture at all has a really high performance under the huge traffic. This solution is really easy to scale. Higher complexity at the beginning of implementation makes it really hard to start our project, and we need to think about a lot of the problems at the beginning of the whole development process. What is good? We have a wide palette of technologies that we are able to use in our project or in our microservices projects, because each of the microservice is a separate app. The bad side of using that approach is that we need to think about how to prove the good security between each of the microservices and how to secure the data and the communication. Okay, the last cons I can think about is that we have increased response time, and that depends on the number of nodes that we need to use to process the request. Okay guys, now it's time to deal with the Micro Frontends topic. So what exactly it is? Micro Frontends are for the frontend the same as microservices are for the backend. It means that we are accommodating the distributed architecture and adjust it to be used in our frontend application. As I explained, in the Monolith approach, we have the single app that closes all of the business logic into the single app. The Micro Frontends assumes that we split our client app into smaller chunks, into smaller app, to be able to manage these closed business features under the single app that can be done by the separate project team. What is important, and it looks similar like in microservices, we have something that is gateway, but let's call it a shell app. The responsibility for the shell app is to make sure that all of our micro frontends, our micro apps, are well communicated and they react properly on the location change or on the global state change. What I like the most about using micro frontends is that each of the micro frontend can be realized in a separate technology. This gives a really big boost for how we deal with the problems. Why? The answer is quite simple. For example, it's not like Angular will resolve all of our problems we will be struggling during the app development. And for some case, React looks better to resolve problems with building the small, fast and efficient module, let's say schedule. And thanks to the micro frontends, we can pick the best technology that will precisely resolve our issue instead of adjusting the one technology to be able to solve all of our problems. Sounds good? For me, it's awesome. So, as I said, the micro frontends offer us an approach thanks to we can build a lot of different apps and make them work together as a single app. But the key to make it work is to provide the good communication between those apps, and we need to choose the technologies wisely, because it's not like we should integrate all of the JavaScript frameworks because we are using micro frontends. No, we are using micro frontends to solve the particular problems we have for our company. And what you can see on the presentation right now is the distributed architecture for the front end and for the backend perspective, and how it looks like being combined together. So each of our micro frontend apps is able to speak with the certain microservice through the API gateway. And that works pretty fast if we don't have to process the data in a lot of different nodes. Why we may want to use that? The question is good, and there are good answers too. First of all, if our backend architecture assumes that we will be creating a lot of microservices that will have a certain responsibilities, we should think about how to create our front-end layer in a best manner. It means that we should figure it out how to communicate our client app with all of our microservices. And If we want to go full on with the distributed architecture, we can think about creating the specific modules that will be responsible to communicate with the single microservice and combine those micro apps all together under the shell app and expose it to the world. But microservices are not the only answer when it's worth to use the micro frontends too. The second thing, which in my opinion is a really great usage example of micro frontends, is when we would like to migrate from one technology to another. Instead of making the revolution in our client app, we can slowly, step by step, migrate, for example, from Angular into the React. And what we get thanks to that approach, we can test our concept, we can test if the migration will be successful before we rewrite the whole application. For example, we can check the single module and prove that our concept is okay and it's safe to be implemented for the rest of the app. As I said, micro frontends give us the possibility to choose technology with the surgical precision. Thanks to the granularization, we are able to use wide palette of technologies. In consequence, the tools that are picked to resolve the business problem can be chosen precisely and give the most performant solution. And now it's time to some Vanilla.js example, which will a little bit introduce you into the world of the micro frontends. As I promised, I want to share with you the simple example of the micro frontends setup. I have defined 3 apps: Game app, Scores app, and Shell app. Each of these apps has a totally separate environment, and we can use whatever we want to resolve the particular problems. The Shell app responsibility is to run our smaller modules, our micro frontends, within the single app and expose it to the user. Inside the source directory, we have our index and the really small block of the code. And what actually is going on here is when we load our document, we want to register our micro frontends. I have created register game and register scores methods inside the game and scores app and attach them to the micro frontend namespace. So this is our first argument of the register method, right? The second argument is the ID of the div where we want to render our micro frontend app. This is pretty simple. Let's check the index.html. Just to quickly jump in, as we can see, those IDs are here. And the third argument, this is the storage. And what's inside? The storage is a singleton instance of the storage class, which defines 2 methods. And what it's worth to mention is the data object that contains the scores. This will be like our, let's say, shared memory between our apps. But obviously we want to react somehow on the value change. And we've got 2 methods: increment scores, modify our scores value, and dispatch the event to inform our apps that, hey, scores has been changed. The subscribe method allows us to subscribe and listen for the previously emitted event and react on the change by triggering the callback function. It's pretty simple, right? So let's check the Scores app. Scores app contains the register scores method. That's obvious, and it has been attached to the micro frontend namespace. And what's going on in here is actually creating the HTML counter element and subscribe to the scores change. Thanks to we have shared our storage instance, it's pretty simple to use it. We can just trigger the subscribe method on the storage class instance and pass the callback function. And after we receive the updated scores, we can update our HTML counter. Window on load block. This is something that allows us to test our micro frontend app without need of running the shell app. So we can work on this module separately in a separate team. Okay, so the game app is also pretty simple. We are creating the HTML button and attach the action for this button. So each time we click it, we are incrementing our scores value inside the storage. This is the separate app. So it's not a scores app, it's a game app, yes. And we have defined the register game method to be able to render it in our shell app. And in the same example, we have the window on load, which allows us to test the game app without running the shell app. One thing worth to mention is that we have to override our increment scores because the storage is not being created inside the game app, it's being passed from the shell app, so we need to somehow mock this API. And this construction is pretty simple, okay? We have three apps: the shell app that renders the game and scores app that display the scores, and game app that allow us to increment the score. Let's check how it looks like on the real life. And yes, I know the minimalism is really huge in here. So each time we click the button, the scores value should be incremented by 1 in this case. Let's check it out. Yes, it works. And how does it communicate? As I've mentioned, we are sending events each time we increment score, and we have this event listener we are using inside the scores app. Does it make sense? Hopefully you understand the very basics of the Micro Frontend configuration. And believe me, this is the really simple raw example. But imagine what you can do more with the Micro Frontend approach. Distributed architecture opens a lot of possibilities for us. Thank you for your attention. Okay, I hope you enjoy this small example. The last slide, I would like to show you that Micro Frontends, it's not an experimental architecture, but it is the tool, the approach that is widely used on the whole world. For example, by Zalando, IKEA, Microsoft, Leroy Merlin, or even Starbucks. Thank you for your attention, and I hope to see you in the next chapters. Tommy K, bye bye.